Check, check, check. It looks like I'm sending audio. How's the volume? Okay, so testing that. Yeah, you can hook up your own laptop. Check, check, check. Check 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Yeah. I mean, this is my normal voice. I think I probably speak softly. Check, check, check. Check, check, check. Yeah. Okay.
Hey, I'm the moderator for this session, so I'm just checking in with you. Okay.
Great. Person?
I'm going to skip out Friday afternoon after the business meeting for a little bit.
But then we're going to turn this one on down for the stream.
Okay.
That one's also available. This only goes to the stream.
Okay. So like when I introduce them and stuff like that, how do you want me? Do you want me to just use that? Because like, you know, or I guess I could talk about, you know, it's just, I just want to know where I'm going to be.
I could pin a microphone on you.
That's a lot of hassle for like.
Instead of this.
It doesn't matter to me. I can just carry around that. Like it, you know, I'm okay with talking in a microphone. You know, I just, like, whatever's easy for you guys, I don't care.
Well, except of course, this one's only stream. So I hope that people in the room don't.
Gotcha. I understand. So
weird.
why don't I just use that when I introduce them then? Like, would that be okay? Like, if you're gonna pin that on them, then I can just use that to introduce people.
Let's pin this on you.
Oh, right, because like we need one for the stream and one for the house.
Yeah.
Okay, all right. How? So you want me to test? You want to test it while I'm talking to Martin? Hi. How's it going? I saw you. Okay. I don't know what you want to do. Okay. I met you last year. I don't know if you remember me. Okay. And so you're doing the first session. Okay. Awesome. So let me see what it says. Yeah. Like I think they're gonna mic you up. So yeah. Okay. So. Okay, so Laniakea. Okay, Laniakea, telling the captivating story. Okay, so how would you want me to read your paper title? Or do you want me just to say, this is Martin? Okay, all right. Cool. Okay, great, awesome. And I have a timer. I'm going to start like right at 10. And how would you want me to tell you?
I would love to know when I'm halfway through.
Okay, I have one room. So you can have 3 minutes at the end for questions. If you want to use the whole 15 minutes for your thing, then you won't have time for questions. So, okay. So do you want me to hold up 7? Okay, so I'll hold up 7, then do you want me to give you a warning just before 15? So 2 minutes left? Okay, awesome. Like I'll either be sitting or I'll just be standing awkwardly close, Okay. All right, awesome. Okay, so and I'm gonna try to keep it like right on time. So at the stroke of 10, I want you to start. So because that's when the timer starts. Yeah, you should go talk to John. Okay. And Shannon and Craig. Shannon. Hi. Okay. Are you presenting with Shannon? Yes? Okay, yes, you are. Great. Okay, so I will try to talk to you. Okay, we're going to start this soon, but I will try to get an overview of like how you want to be presented and stuff like that before Martin's thing is done. Because like there's going to be a little bit of time in between to transition. So yes, so I'm gonna. Sorry, I'm trying to do a bunch of math in my head. So he's gonna have time for questions at the end. Like, everyone gets 3 minutes at the end. And so, how would you want to be introduced or anything like?
I don't know.
Do you want me just to say your guys' names?
Testing 1, 2.
Do you want me to read your paper? How would you like to be introduced?
Just for the stream.
I have to start. So I'll grab you guys in a second so you can think it over. Okay.
Can you just say our next paper, and we can introduce it?
That sounds good. Hello, everyone. Oh, that's loud. Holy. Okay. I'm Jackie Bauman. I'm going to be moderating the... Okay. All right, so I'm Jackie Bauman. I'm going to be moderating the paper session today. We have Martin Ratcliffe for the first paper session. So here he is.
Thank you very much. It is fantastic to be at GLPA and wonderful to be presenting a short paper to you today called Laniakea, Telling the Captivating Story. I'm attending here partly, obviously, with Evans and Sutherland, but also Wichita State University, who, even though I left Kansas 3 months ago, I still teach remotely, which is a lot of fun. And I teach intro cosmology, surprisingly enough. And so most of us, I think, in this room and in the other room and out in the universe, often show the galaxies on our dome and just say, isn't it amazing? There are galaxies everywhere. Look at those clusters. The Milky Way is in the middle. And we generally tell the story that there's an overall expansion of the universe. And that's the Hubble constant, which we know is 72 kilometers per second per megaparsec, or maybe it's 68. That's a deeper story. We won't go into that in this talk. So the other interesting and also compelling but complicated story to tell is the cosmic microwave background. And I love this picture of the cosmic microwave background because it actually reveals our Milky Way's motion through the universe with reference to the background. So often if you're trying to tell students about this, a good idea is to reference, driving in a car and looking at the horizon and seeing how you're moving relative to the horizon. This is our motion relative to the horizon, defined by the cosmic microwave background. And we're moving at 552 kilometers per second in the direction of Hydra, which is the red glow there. Now this always confuses me in this picture because the red glow is showing the warmer region. That's the motion that we're moving towards, and we're moving away from this lower region. And if you know anything about Doppler shift, the red part is blue shifted, and the blue part is red shifted. So we astronomers love plotting things back to front and upside down, and we also have this. So you have to be careful when you're describing this. Just remember we're moving towards the red side. So that's going to come in later in our story. So I want to try and unravel how we tell a story in our domes about Laniakea. So Laniakea was in my first slide, which is the beautiful large-scale superstructure, supercluster that we are a member of. And it looks beautiful, but how do you tell the story? And I've struggled with this quite a long time, and I came up with a technique, visual technique, to begin to tell the story. One is we have our local group of galaxies, and our Milky Way is in the center of this small distribution. This, by the way, is a dome view, so this is front and center. Hopefully everybody in this room can read a dome view. And, but lesser known is that our local group of galaxies is actually in a plane. So if this is a plan view, and if you rotate this 90 degrees, you get this. It's like a thick disk. Who knew, right? It's like, wow, that structure's amazing. So I love telling just that part of the story to an audience because they've never seen that either. And I wonder how many of us have actually told that. Even more amazing is if you back away, this is the Virgo cluster, and it's in line with that disk of the local group. Wow! That's a story, right? You can actually get your audience thinking about I'm going to use the word geography in the wrong context, but thinking about structure and actually understanding it. And actually there's a void above and below our local group. And again, I won't go into that story, but there are two voids, and we're sandwiched in between them. So that's cool. And we have the Virgo cluster here. If you back away a little bit further and draw a line through that Milky Way local group plane and the Virgo cluster, you kind of start seeing a larger scale line across the universe, and we call that the supergalactic plane. It's one of the definitions of the orientation of our Milky Way and everything to that supergalactic plane. But also, and this is key, that's the XY plane, which is going across here. We're going to have a vertical plane here, which is marked by the plane of the Milky Way. And not only that, there's a visual cue because the Milky Way blocks seeing any galaxies in that direction. So we have a zone of avoidance. There's a whole gap in this distribution of galaxies that is so clearly obvious on the dome that your audiences will just get that. And it's a visual reference, even though you can't see the Milky Way, that's where the Milky Way is oriented, perpendicular to this plane. So that's part of the introduction to that story. So what I did in the dome is just build a sequence, and I'm going to just step through this and then I'll show you the sequence. But really trying to show this supergalactic plane. And then, if you simply orbit this, you end up going below the plane and up, and it's pretty crazy. But I wanted to rotate above the plane all the way around. And so I used a little tool in our software that allows you to do that very, very smoothly. But I want to talk about, what is Laniakea? What are we talking about? So to do that, I introduced the idea of a watershed. And a watershed is an area of the ground where rain falls vertically down towards the ground and then is minutely diverted away from that path due to the terrain. So here you have mountains and you have water starting to flow down tributaries. So what happens in astronomy is we have the overall Hubble flow of the galaxies expanding, but there's things called peculiar velocities. I encourage you not to use that term in front of an audience, except this one. These are the minor velocities that are deviations away from that overall expansion. And it's a watershed. It's where giant masses of clusters of galaxies are diverting the motion of these galaxies going away in the Hubble flow and actually being diverted down these tributaries, which is the gravitational field equivalent to a terrain on the Earth. So you can kind of draw that analogy. And so now this picture, even though it's still complicated, I'm showing the entire Laniakea structure, is showing where galaxies are actually being nudged in different directions. And you'll see that there's, I'll just flip this over, you'll see that there's a preferred direction, which is over in this direction. I also use a little visual cue, which is an XYZ little pointer. And so the X and the Y in green and red are showing the plane. And then the Z-axis is showing the vertical direction. So I'm going to rotate around the Z-axis and just show you a few little visuals of Laniakea. You see the Milky Way is in the center, right here. And we're obviously being pulled. The interesting thing is the Virgo cluster is right about there, which is 65 million light years away. And you can see there's an awful lot of mass pulling galaxies off in a different direction. And this is related to more distant clusters like the Hydra Centaurus supercluster and other superclusters in that direction. But visually, it's an interesting technique just to rotate very carefully around this picture. Sorry, I jumped too far ahead. And then the final piece is let's tie this in to that cosmic microwave background picture, which is showing us the direction in which we're moving. And so you want to show this all together. And when you do that, and I did this on the dome, and I went, wow, it all ties together. That mass right in here is also the direction we're being pulled, shown by the cosmic microwave background. So you have three strands of this. You've got the data points, the galaxies. You've got the direct observation of the cosmic microwave background. And you have the Laniakea structure as well. And it all ties together in a visual package. It's the entire universe. So now I'm going to quit out of that and show you the movie. It's not really a movie. It's many of you have Digistar here. I'm just going to show, the way I did put this together was create my viewpoints and then connect them all together with ShowBuilder. And those of you who use Digistar know that ShowBuilder will automatically create a smooth navigation between all the frames. I need to just cue this up. How long do I have left? 5 minutes. Perfect. Well, plus questions. Yeah, with question time. So this is 4 minutes. So what I'm going to and the key to telling this story is to maintain the motion, because the moment you stop, your audience lose their reference points of where they are. And this is a horribly complex view that I'm trying to simplify. So in between these various steps, which I'll walk through, I do some very gentle motions around the y-axis, keeping the zone of avoidance vertically so that we're just rotating the thing around. And they start getting reference points as to where the large masses are, which are, this is the Tully galaxy data set. You can use any galaxy data set that you want. And you just continually rotate around, telling the story that I've just introduced. And you start seeing the green stuff in the middle there. Is that a pointer? Wow. The green in the middle here is our local group. We're now looking vertically down on the plane. And then we'll rotate back. And you'll notice the Virgo cluster right here, and you see it goes into that straight plane, and then we rotate back out into the perpendicular view. So this is really defining our local structure, just much like we do on Earth with an equator. We're looking at the whole galaxy data set here. It's kind of an equator in a way, and it gives a strong visual reference to your audience. And then as you back away and show the large structure with the supergalactic plane, you can then bring in Laniakea. Now, the moment you bring in Laniakea, if you're like me, you go, whoa, what is that saying? So you have to build this story using careful scaffolding of visual references, which is what I've tried to do.
Great. Martin, you are in question time.
I'm in question time, thanks. So I'm going to let that run in the background just to show that. I will point out one other thing, and then while it runs, we'll do some questions. I did want to mention that final word for teachers, education standards include the following. Earth and its solar system are part of the Milky Way galaxy and is one of many galaxies in the universe. So you have a reason to describe the details of this, because it's not just we're part of the universe, but we're part of structure in the universe, which is really fascinating. So I'll stop there. I'll let this run. And if there are any questions, I'd love to take them.
Great. John, how do you want me to do questions, like with the microphone? Okay. All right. All right.
When Percival Lowell looked at Mars, he thought he saw canals because his brain was making patterns out of things that didn't necessarily exist. How do we know that we're not doing the same thing here?
So you have to believe the scientists that did the work. I was once told when I talked about Laniakea, oh, you drank the Kool-Aid. These are very, very, very difficult observations to make. They're made largely with Brent Tully and Helene Courtois, who's in France. And I've worked with both of them on some of this visual stuff. And they describe this very well. Helene has a fantastic book describing the whole process of getting to this. And I recommend it. It's a little small book about Laniakea and how you find this. And I've used a lot of threads. Just realized that's a pun. A lot of threads from her book to tell this story and try and unpack it. It's very complicated when you start working on it, and so what I'm trying to do is keep it simple. But yes, there is a lot of interpretation into this data. Now, it's also fair to say, and I didn't it's actually visible on the end, when you show this on a dome with the zone of avoidance and Laniakea, you see that the right-hand side of the dome is relatively sparse of superclusters, and the left-hand side of the dome is really packed with them. And so you have this visual reference of, yeah, that's where the gravitational mass is. So something's happening.
This is your last question because you're almost out of time. Okay.
Okay, so first of all, I want to say thank you for this talk, because what you're doing is making sure that we're focusing on the fact that we can tell complex, difficult stories. You just have to take your audience with you in a very clear and step-by-step way. Can you talk about some feedback, any feedback you've gotten about showing this to public audiences? Like, what's the response that you've gotten? Do you hear those oh moments or aha moments? Or can you just talk about some of that feedback, or give us some sense of what it's like to do this in front of an audience?
That's a great question. I think what I'm going to do is, well, first I'll be honest and say no. I have shown it to Planetarium audiences. You are the second one. I showed it at last year's Digistar user group, and people love the visual and they love the story. And I think what I'd like to do is get this kind of content out there in this format so that people can test that. So I think it's an area that is worth testing, and you and I have talked cosmology for decades about, how do you test what the audience can know and what they understand from this. And so that level of assessment still needs to be done.
Great. Great, thank you, Martin. Next we have Shannon and Craig. Okay. So I'll tell you at 3 minutes, right? Okay, awesome.
Hi everyone, I'm Shannon Schmoll. I'm the director of the Abrams Planetarium. You're going to hear plenty from me, so I'm not going to talk much this talk. So.
And I'm Craig Whitford. I'm a volunteer at Abrams Planetarium. Worked with Shannon now almost 8 years, and brought me in when there were a couple of Rubbermaid tubs filled with meteorites, including Michigan meteorites. Okay, what a surprise. And we decided that we had to do something with them. So I'm going to take you on our journey of creating a brand new public interactive display. But first, have you all had a good day? That's probably a bad day. This one's been passed around here. I've had several people come up and show it to me. First of all, it's not a meteor. It's a meteorite. Because it's not a meteorite until what? Hits the ground. Hits the ground. And since it's so close to Halloween, I got a rock. Boy, believe me, if it was a meteorite, I'd be more than happy.
I've been gifted many rocks from him.
So how many in here, just by a show of hands, have held a meteorite? Or have not held a meteorite? I guess that's a better way to put it. Who hasn't? Couple. Okay. Shannon, aka Vanna White, is going to pass, and now you cannot say that you've never held a meteorite.
Do you want help?
You're holding
You
four
Okay.
point almost 6 billion years in your hands. Okay? Literally the only thing in astronomy that's come from space that we can all touch. And there's no such thing as an ordinary meteorite, even though there's an ordinary chondrite, which is a stony meteorite and represents about 94% of those that do fall to Earth. So our new exhibit is called Asteroids, Meteors, and Meteorites. Oh my, and that doesn't stand for Ohio and Michigan. So could be some confusion there, and I'll talk about Feeney later in the program. But in 2015, when the meteorites were brought out in the 2 tubs, they were wrapped in paper from the mid-90s. Our meteorite exhibit had been off display since then. The last inventory of it was done by Vondel Chamberlain in 1973 before he went to the Smithsonian. So between 1973 and 2015, did things change? You bet. The Sahara Desert was a gold field of meteorites and meteorite types that were discovered. So we put our heads together and said, you know, it'd be nice to have an exhibit, put them back on public display, and let the thousands of kids that come through the planetarium, and adults, kids as well, enjoy our meteorite collection. And so we at first looked at space rocks, Michigan, meteorites, and beyond, bringing the solar system down to Earth. In order to do this, Shannon and I worked on a grant proposal to the Institute of Museum and Library Services, and we submitted our application in 2016. You have to wait nearly a year to find out whether you're successful or not. And in 2016, as you can see, they received 558 applications, nearly $105 million in funding. Wow. Now, mind you, we were asking for money for a planetarium, for a meteorite collection, and no one had ever done that. Fortunately, we were lucky enough. We were among the 132 projects that were selected, totaling over $19 million in funding. We received $97,000 from my MLS, with another $83,000 in funds from Michigan State University in the form of time and staff for advisors. DART Foundation, that makes everything styrofoam and beyond. Its world headquarters is in the county that the planetarium is in, and they have donated to projects before. They gave us $15,000 for equipment. So we felt very fortunate when it came through. So I'm sorry, I created this on my laptop and we've transferred it over to Shannon, so there's some shift. But we wanted something that would be a wow factor for people coming in. So our artist that we had hired created this wall design that featured each of the planetary objects, the Moon, Mars, and the asteroid Vesta, and a sidewall over there showing a view of Earth from space. Now, as part of this wall, we had to prep it. It was covered in carpeting, all the walls. That double door system there had to have an insert built and installed and then covered. And then the wallpaper put up, and that was all one piece. Agio Designs out of Kalamazoo did it for us. And you can see our specimen cabinets right there too. One important factor with our exhibit was lighting. And we've viewed a number of meteorite exhibits in that, and they all seem, because they're in museums generally, science or otherwise, and the lighting is usually dim for the other artifacts in the area. but we needed a well-lit area. And so that wall would also serve as a selfie background. Attached to that wall were 3 reading rails for each of the planetary bodies. There was a meteorite that was put inside a disk with a finger hole that they could touch a meteorite from the moon, Mars, and Vesta. In addition to that, we created a sensory 3D sculpted crater from each of those bodies so the kids could come by and touch them. So if you were touching the moon and somebody could take a portrait of you with the moon behind you. Then we had the main display. The meteorite collection held 6 at that time out of the 9 known Michigan meteorites. 6 out of 9. Now, you know how you're always afraid that things change during a project? That happened here. But this is the main display under construction with just a rendering of what it should look like at the end. And, well, we'll see that. It fell out. It'll be at the end of the program. We also had 2 specimen cabinets with 2 acrylic toppers, and those are provided by the DART Foundation. Each of the drawers would answer a commonly asked question about meteorites. For instance, how do you know they're meteorites? Where did they come from? What are meteorons, which we see all the time? And, did meteorites take out the dinosaurs? We did sketches and then sent them off to our graphic artist. And these are the acrylic toppers that allow us to display, change out displays in that of our meteorite collection at the planetarium. That one down there was meteorite number 11. Now we had 6 out of 9. And before we were done, we had 11 Michigan meteorites. We had 1 fall, 1 found, and we had to chase down a couple of others. The specimen cabinet drawer designs had to be graphically pleasing as well and contain enough information to capture their interest, along with specimens. And you can see, how do we know meteorites are from space? Did a meteor wipe out the dinosaurs? And is the sky falling? We talked about micrometeorites in that drawer. But, Feeney is in each of the drawers. So say hello to Feeney. We sat down and we needed to brand our new exhibit. We're a planetarium, and now we're kind of a mini museum as well. And so there was an artist, an illustrator on campus that did children's books. We invited him in, showed him what a well-oriented meteorite looked like with flutes and everything. And so as you can see, Feeney's head is that oriented meteorite, the nose being the point. And then adding color, adding meteorites, expressions, everything, and of course the Sparty flag. We have Feeney, iron, nickel, the most common elements in meteorites. So that's where Feeney came from. And Feeney's been a hit. We have a 4-foot cutout that kids can stand next to and have their photographs taken. And when you have something, an exhibit like this, especially since it was in the south end of the planetarium, we decide to name it after Vondel Chamberlain, the Meteorite Gallery. Without Vondel, we would not have our meteorite collection. He is the one that started the display way back in the 60s at the planetarium. And this is that main exhibit that the photos fell out on. And that one slide is right there, and that features all 11 of the known Michigan meteorites. The map outline with each of the counties where meteorites have been either found or fallen are displayed on that, and that is from the original exhibit. So we took a part of the old exhibit, added it to the new to do it. And you can see our walls with the reading rails attached here. And they're easy to dismount should we ever have to reopen that wall there. And you can see our stand-up Feeny right there. And then our specimen cabinets over on the far right with the back side of the main display with a...
This is your question time too. So.
Is it? Okay. Yeah. With that, and I'm just about done. And I mean, why do we do this, right? We get thousands and thousands of kids coming through the planetarium. They're our future. So this is half of my grandkids. They were out for the opening day. We've got other people looking at everything, and that's my granddaughter trying to impress me with a meteorite. So she loves space. So as part of this, we produced Exploring Meteorite Educator Outreach Kits, and I've got them over on display on the table there if you'd like to take a look. We will have 5 in our planetarium that can be checked out by educators, librarians, you name it. So leaving you with just a couple of quotes that are on our exhibit. This one from Mae Jemison. When she looks up to the stars, it still gives her hope. And then we also have a quote from a geologist. Every time we handle a meteorite or just gaze at it, we are likely to feel the shiver of excitement of the mystery of reaching out and making contact with the unknown. And boy, isn't that true. But, you know, adults love them just as much as kids do. So if you don't have a meteorite collection, start one. If you don't use them in your outreach, you probably should. We've been very successful with that. So any questions, Shannon or I?
Oh. Give me a second.
The most common question I get is, I found something in my backyard, is it a meteorite? What advice do you have for that kind of inquiry?
Well, most generally, 99.999% of the time it's not. I take them over to our drawers and show them the meteor wrongs that we have seen and everything. Most of the universities in the United States have stopped accepting public people coming in with stones. Arizona State, I think, does it one day out of the year. There is a lab out on the East Coast that people can submit a sample to for $25, and they're just as happy to tell them it's not a meteorite too, from that standpoint. But you can do specific gravity tests that are very easy and simple depending on the size of the rock. But generally, if it's not magnetic, in other words, a magnet's attracted to it. Achondrites don't have any metal in them, but they're the planetary meteorites, and they're very rare. Chances are it is not a meteorite. So.
Okay, this is your last question because it's time. So go ahead.
Hi, Jack Daleski. We met at the state meeting. So I just wondered if you had any pro tips or anything you learned when it comes to purchasing meteorites or picking out specimens.
Okay.
If people,
Were you able to hear that?
Yes.
Okay.
Yeah. It's best to deal with those that are well established in the meteorite business. I have been now studying meteorites for almost 20 years. There's a lot of fakes online. And chances are, if it comes from China, it's probably been manufactured, including pallasites, the rarest of the meteorites. There's just a brand new pallasite that somebody in China is producing. So, yeah. Yep, you can always give me a call too, and I'd lead you in the right direction. So,
Thank you.
All right, thank you.
All right, that's it for this session. So thank you, everyone. I don't know if it's my job to tell you what's next, but there's a break. I'm just going to do it anyways. There's a break with poster viewing now, so have fun. Yeah, go ahead.
Oh, yeah. You can bring it up, but we have all of ours up here that we brought
How was it when Jack was talking in it?